Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of zeros of quadratic functions. This is standard A.7B in the great state of Texas, and we are using item number 16 off the 2016 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have this statement here about k of x, and that is in our standard form. So we've got the negative x squared minus 2x plus 15. Now before we go any farther, that negative x squared is really going to mess us up, so we need to factor out a negative 1. So it's going to help us if we can just take a negative 1 out, right? And we'll just end up leaving that as just a negative rather than negative 1, but we'll keep the negative 1 right now. So if we take a negative 1 out, that's going to leave us a positive x squared, which is really what we're looking for. Positive 2x minus 15. All right, so that's what we're looking for here. And this is our standard form, right? So our standard form, remember, is going to be k of x equals ax squared plus bx plus c. So that means our a is going to equal 1. Remember, we factored it out. B equals 2, and C equals negative 15. Well, how does that help me? Well, I'm trying to get into this factored form. So the standard form is written up above. The factored form is x minus u, x minus v. Because these, if I can get it like this, I can say my u and v are going to be my zeros because I can set each of those to 0 and then solve for the x. So what I'm looking for is to change it from this form into that form. So how do we factor that out? Well, one method is the diamond method here. So what we do is we take our a and our c, we multiply them. So what is our a and our c? Well, a is 1, c is negative 15, so negative 15. We take our b, right, and we just write that down. That's just a 2. Okay, so what factors can we get that multiply to negative 15 but add to positive 2? Well, that could be a 5 and a negative 3, because we need to multiply to negative 15 but add a positive 2. So what I'm going to do is I'm going to rewrite this right here, but I'm going to take this middle factor, this b term here, I'm going to rewrite it with my new terms. So I'm just going to leave that as negative, and we're going to say x squared, but instead of that plus 2x, I'm going to do a plus 5x minus 3x. That's what I got from right here. And then I do a minus 15. And now I'm going to group these here. And I'm going to say, you know what, I want to do this section and then this section right here inside this larger bracket that's being multiplied by negative. And I'm going to factor out something that's common. So I'm going to just do like this and say, what can I take out of the x squared plus 5x? Well, the only common is x. Okay? So that's going to leave me with an x plus 5. And then, what can I take out of this negative 3x minus 15? Well, I can take out a minus 3, right? And that's going to leave me with an x plus 5. And if you're thinking, I just wrote x plus 5 twice, you're right. That's what I'm looking for. Looking for a common factor. So now I can factor out the x minus 5, right? And what is that going to leave me? Well, that's going to leave me with negative x plus 5. And the only thing that's left in there is this x minus 3. And now I've got my factors here. I've got this in my standard form. So what are my zeros? Well, remember we can set each of these to 0, right? And we can solve for them. And so if we were to set this x plus 5 equals 0, then x is going to equal negative 5. We can do the same thing here, right? X minus 3 equals 0, so that means x is going to equal positive 3. So we see that right here. We see our factored form here. And so we know that our zeros, if we were to graph this on the this parabola on the axis here, we know it's negative, so it's going to be downward facing. It would have a 0 at negative 5, a 0 at 3. We don't know where the vertex is quite yet, but it would look something like that. So our answer is going to be G.